Tonight, what we're going to be talking about solutions and how do we measure solutions in their given concentration. Okay, so let's go over the basic terms again about what is a solution. So there are three parts to a solution. Number one is the solute, and the solute is the solid that you are dissolving. Solvent is what you are dissolving the solute in, and solution is the combination of them. So as I've talked in the past, the solute for like a Kool-Aid situation, the solute would be the sugar, the solvent would be the water, and then the solution would be the Kool-Aid. Visually looking at it, solute would be the solid, and then you have your solvent and all of their particles. What's going to happen is as you make a solution, they are going to dissolve, and the solute is going to break apart and make up your solution. So the solution will have particles of both the solute and solvent floating around in it. All right, so how do we measure concentration? In the past, the biggest way that we've measured concentration is by the term of density. And this we usually did for solids or liquids, and we did it grams per milliliter was the big one that we talked about. For solutions, what you tend to do is do it in some term called molarity. And you've probably seen this on a lot of different chemicals that you've picked up in this room or in different readings that you've done. It'll say like 2 and then a capital M. That M stands for molar, and that is a concentration of its molarity. And molarity is the measurement of an amount of solute for a liter of solution, and that amount of solute is in moles. Okay, so molarity is in moles of solute for every liter of full solution. When you put a number associated with its molarity, it turns into the word molar, which is abbreviated with a capital M. Okay, so if you're talking about its molarity and you put a number right before it, it goes to like 2 molar. So its molarity is 2 molar, or the molarity of the solution is 3 molar. So as soon as you assign a number to it, it becomes molar. So looking at these various molarities, it's based up on the number of particles or the moles in a given amount of solution. So if we're comparing A, B, and C, okay, looking at its molarity and its concentration, notice that the volume of the solution is entirely the same. So we would just be counting basically particles and represent, say, each particle represents a mole. So looking at this, C would have the least concentration or the lowest molarity number, meaning like it would be a 1, let's say, 1 molar, and that has less particles than something that, let's say, is B, which would be like, let's say, a 6 molar solution. Okay, so the higher the number, the more concentrated, the more particles you have for a given amount of space or liters of solution. Okay, looking at then these last two, E and F, okay, notice that F has 4 particles, E only has 2 particles, so therefore its molarity is greater in F than in E. Now, if you were comparing, let's say, all of these guys, it's a ratio. So if we were comparing D to, let's say, F, okay, there are actually more particles in F for every given space than in D, because even though both have 4, okay, this 4 is in 50 milliliters and that is in 25. All right, there are 3 formulas that you're going to need to know to be able to calculate molarity, and they are the top one, which is molarity, which is abbreviated as capital M, or moles over liters. We always write it this way, but understand that this is if you kind of like break it apart into their individual components, is the moles of the solute divided by the liters of solution. Okay, and remember, liters of solution is the whole thing with the solute already in it and the solvent together. So that's how you calculate molarity. Another one is this beautiful triangle, okay? How you do that, once again, with the triangle is whatever you're trying to solve for, you're going to cover it up. So whatever let's say I'm trying to solve for molarity. So I'm going to cover up my M. And what am I going to do? Well, it shows me to take my moles and divide it by my liters. Okay, now if I wanted to, let's say, solve for liters, okay, I'm going to take my moles and I'm going to divide it by my molarity. And let's say I wanted to solve for moles. I'm going to take my molarity and times it by my liters. Notice all of these have liters as its main volume. You need to be in liters. A lot of times we'll give you the calculations in milliliters because that's how we tend to measure things in the science classes, but you will have to always convert it into liters. All right. And then the last one is grams over molar mass equals molarity times liters. Okay. So when do you use what formulas? Well, this triangle is what you use when I ask or give you moles. Okay. And this one, this grams molar mass, is when I ask or give you grams of a substance. Okay. So either of these two triangles are really your primary. This just is the formula, and these two other formulas below are kind of derived from that major formula. All right, so let's try to do some of these practice problems. A sample containing 2.3 moles, so I see moles right away, of sucrose was mixed with water. The sucrose completely dissolved, making the total volume of solution 1.3 liters. What is the molarity? So I'm going to look at what I'm given. I'm given moles, I'm given liters, and I'm asked for molarity. So out of these formulas, which one would you use? Well, you're going to want to use the one with moles, okay? Why? Because I gave you moles, so try to use that. So how do we do that? So we're going to take 2.3 because we're solving for molarity, so I'm going to cover that one up. So we're going to do moles divided by liters. So it's going to be 2.3 moles divided by 1.35 liters. It is in liters, so we're good to go on that. We don't need to convert it. And when we get this, we get 1.7037, but rounded to the 2 sig figs because of that 2.3, it would be 1, 2, so 1.7 molar solution. All right, what is the molarity of 245 grams of H2SO4 dissolved in 150 milliliters of solution, and I want the molarity. So looking at this, I give you grams. So which formula are you going to use? You're going to use the grams formula. Okay, so what we're going to do is we're going to take our 245 grams, which is how much we dissolved, okay, of H2SO4, divided by the molar mass of H2SO4. This has 2 times 1 plus 1 times 32.1 plus 4 times 16. So we get a total molar mass of 98.1 grams. That equals my molarity times liters. In this case, I'm trying to solve for molarity, so I'm going to do M and solve for and I'm going to need my liters. Problem is I give you 150 milliliters. So how are you going to do that? You're going to move over 150 milliliters. You're going to move that decimal over to the left. 1, 2, 3. Okay, you're going to move it over 3, so you get 0.150 liters. Okay, you're always going to be I'm going to let you know, in this class, we always use milliliters and we always go to liters. So you're always going to just be moving it over 3. If you didn't want to do that method, you could always use that conversion, 150 milliliters, and then do your dimensional analysis of 1,000 milliliters for every 1 liter. So milliliters cancels, and once again, you're going to get 0.150 liters. So this ends up doing the exact same thing as moving it over 3 decimals. Now, to solve this, I'm going to take 245 divided by 98.1 divided by that 0.150, and when I solve that, I get M equals, so my molarity equals 16.6497 molar, which means rounded to the 150 has 2 sig figs, 245 has 3, so I'm going to round to 2 sig figs, so it's 1, 2, so I get 17 molar as my final answer. Last problem is as I ask you, how many grams of H2SO4 do we need to make 750 milliliters of a 2 molar solution? So once again, I'm going to use that grams formula. I'm just solving for something different in this case. For this one, I'm going to be solving for that grams. So grams is going to be my X variable. My molar mass still from H2SO4 from the previous problem was 98.1 grams. That is going to equal my molarity, which is 2.0 molar, times my liters. Once again, this is not in liters, so I'm going to move it over 3. 1, 2, 3. So I get 0.7500 liters. Multiply that out, so it's going to be 2.0 times 0.7500 times 98.1 to get that 98.1 out and solve for X, and I get 147.15 grams. Rounded to the correct number of sig figs, which would be 2 from that 2.0 because 750.0 has 4. It would be 1, 2, so 150 grams of H2SO4. All right, hopefully you have an understanding of this. Make sure you understand that you use the triangle when you're trying to solve for moles, and you use this grams formula when you're trying to solve for grams, or I give you grams. All right, have a great evening.